Hey everybody, thank you for joining us. We're going to be looking at optimization for low-end devices in React Native today. To give you a little bit of an overview of what we're going to cover, firstly, we're going to go through a real problem that we faced on a project about a year ago. We're going to talk about why optimization matters, experiments and results that we ran to improve the state of our application, and some cool tools and libraries on the horizon that you should keep your eyes peeled for. All right, let's jump into it. So let's look at a little bit of context here, and I think this will help. We were working on an app for a client in the fashion market. The main flow of the app was that the user would go ahead and scan a barcode for an article of clothing. They'd go through a number of steps. So we had a multi-screen form, and they would select things like the product category, what size the article of clothing was it, I don't know, a shirt, a trouser, what have you. And then they had some like text inputs for certain things where they needed numerical inputs, just some basic data. If we want to take a look at the flow, it was something like this. So we've got some mock-ups here, but step by step, they'd go through this, first scan the barcode, go through all of the inputs, and they'd be given a confirmation screen at the very end saying, this is what you've selected, and you can confirm it and save it. Cool. So we went through this process. It was like a 10-week long project, got the app perfected in terms of a user perspective, and we wanted to release it out to the wild and see what it was going to be like. Generally, while we were testing, everything was going smoothly. And once we got it out, we found that a lot of users were feeling like the app performed something like this. But unfortunately, others reported more of a sloth-like experience. So a bit of a mixed bag. And to prove to you how bad it was, I've got a GIF that someone sent me from a video recording of this app. So you're going to enjoy this one. So if you pay attention there, they click. It's great, isn't it? So not looking too good. And we calculated the average time between clicks, and it was 6 seconds. This is fine. Everything's good. All right. So I want to take a step back. Why does performance matter and optimization matter? I mean, it's obviously awful UX, so you want to fix that just for that perspective. But taking a step back, 3 main reasons. From a user acquisition perspective, if you look on the left-hand side, that's a chart of the distribution of phones in the UK by manufacturer. Apple's got roughly 50%, but the rest are Android phones. And the top 3 brands in the UK are Samsung, Huawei, and Motorola, all of which have a pretty comprehensive set of budget lower tier phones. So a large portion of the UK market is going to not have the fanciest top-notch performing phones. And that's something that you're going to have to look at from a business if you want to actually acquire those sets of users. Google study looked at Furniture World, which is an e-commerce platform for furniture. They found that by reducing page load times by 20%, conversions for users actually increased by 10%, which is massive. So it definitely has an impact from a business perspective. If we take a look at performance monitoring and that type of stuff, regardless of lower end phones, you're also going to be your optimizations are also going to benefit high tier phones. So there's a lot of analytics available to users now on battery usage. Users can typically sense when you're using a crap ton of CPU. So if your app isn't performing well, it's becoming a resource hog, there's going to be data on it. And you don't want to be removed just because you are draining the battery out of someone's phone. I think WhatsApp had this issue a little while back where with the latest version of iOS, they were consuming a lot of battery. And people were reporting like, what's happening here? Why is it taking the vast majority of my battery life on new iPhone 14 Pros, which are meant to have a massive battery life? So people will catch on to it. So it's important from that angle. Lastly, and possibly the most important, sustainability. So optimizing for performance ultimately means that you're building more sustainable apps. I don't want to go into it too much, but a colleague of mine, Henry, wrote an article called How to Build Mobile Apps Like the World is Ending. It's a little bit melodramatic, but he's talked about some of an overview of why sustainability can be improved and why you should improve the sustainability of your app through performance optimizations. Nice. So let's jump into the experimentation section. First question that came up was, is this an OS issue or are we facing a hardware limitation? Pretty simple experiment on our end. we basically just tried different phones with Android and iOS. So on the iOS side, we didn't go for like the top tier latest iPhone only. We also looked at a phone from a few years ago, like the iPhone XR. On the Android side, we looked at the OnePlus 7, which was from a few years ago, and the S21 Ultra, which was the flagship at the time. And we quickly realized that this was not an OS issue. The apps were performing pretty well across these phones with sort of average to higher end specs. iOS was a little bit better, but overall they were acceptable, quick, smooth, snappy, responsive, not an issue. We went back to the user and tried to get a sense of what they were using, and we came across this tier of phones, which are the Deceiving New Phones. So if you take a look at this phone, you see there's like 4 cameras on the back, there's this fingerprint sensor, there's a massive OLED display that looks better than some of the iPhone screens, and you think, wow, this is a great phone. And on top of that, Samsung's selling it for like 200 quid. So what a bargain. It's all a lie. It's a facade. What you'll realize very quickly is because you cut down on the cost so much, you have to compromise on the CPU specs. So on the left is Samsung Galaxy A21s, a 2021 phone with a single core score of 169. Compare that to the iPhone XR from 2018 with a single core score of 1,100. Not looking very good. To put this into perspective, this is the same CPU score as a Samsung Galaxy S4, which was released in 2014. So this class of phone is actively being manufactured and being released out to the public and is being purchased at a very high quantity. And so you'll have a lot of users that are going to be using these specs. Cool. So let's go through our experiments now. Starting time between clicks was 6 seconds, as you saw. So we went through a few experiments and measured out how much the average time would be between each navigation transition. And over time, we saw what were the different experiments that yielded the best results. So firstly, batching requests to the backend. We weren't awaiting requests when we were updating our backend models, but on every single screen in the multi-page flow, we were firing off a fetch request to the backend to say, patch this specific resource that just got inputted by the user. Despite not awaiting those requests, there was a slight amount of time that was added on. So by batching the request to the very end of the flow, we found that there was less work in between clicks. And there is a trade-off that if your changes are left midway, nothing is saved, so you need to go through that flow again. But in our use case, that didn't really matter. And you could debounce the requests anyway if you wanted to, and just reduce the amount of requests rather than batching them all at the end. So when you look at the flow, when we looked at previously, you've got those pushes on every single transition. We ultimately just modified it so that the push out to the server was happening at the very end when you confirm the changes. So surprisingly, this actually reduced the average time between clicks by a second. So not great, but something. So we had the ball rolling. So it was a good start. We then started deep diving a little bit into React navigation. There's a lot of talks that have been done over optimizing React navigation because it turns out navigation is a hard thing to get right. So there's a few tips and a few things that you could be looking out for. Firstly, the new sort of API for React navigation is that you would call a navigation.navigate to automatically let the library figure out which type of navigation to execute. So this is kind of implicitly going to handle that logic under the hood. We found in a few cases it wasn't actually doing that. So we didn't need some screens in the background, but it was still keeping them in the stack. You can go through manually and see what these cases are. And if you have cases where navigation.navigate isn't doing what you would expect it to, you can manually reset it. It's not great, but it works if you have too many active screens there. Generally, as you have active screens, obviously it's going to be a memory consumption because React navigation will keep that and keep the state of those components in memory so that at any point the user could go back. Combining feature stacks when possible. So a common design paradigm or issue that I've seen is that you'll have a root navigator, and then inside of it, you'll have an authenticated and unauthenticated stack. And then within the authenticated stack, you'll have a feature stack for every single part of your application. And then those will probably have some feature stacks in them. You get a pretty deeply nested tree. And that is explicitly what the React Navigation docs tell you not to do. And we'll take a look at an example in a second. So that's something to look out for. Another quick win is if you don't need too much customization on your navigation stuff, you can use the native Stack Navigator as opposed to the Stack Navigator. So the Stack Navigator uses JS for parts of the implementation. It's going to be slower on that layer, but if you don't need that customization, you can go for the native Stack Navigator, and it's fully delegated to the native layer. Lastly, make sure you're on the latest version of React Navigation. So you might have some old, outdated dependencies. The Open Door team found that they actually had massive performance gains, something to like the degree of 60, 70%, just by going from version 1 to version 6. It's a big jump, but there's a lot of work that's been done over the years. So things like React native screens being implemented as part of React Navigation as a default way to render screens. These are all big, big performance gains that have been realized over the past few years. So you want to use them, update your dependencies. When we're talking about the nesting, just to give you an example, so that's from the React Navigation docs at the very top. It says, don't deeply nest view hierarchies. It's going to be bad for performance. Explicitly mentioning lower end devices, actually. But if you look, there's one Stack Navigator. They've included both the authenticated screens, the unauthenticated screens, and then some common screens as well. And they use stack groups as opposed to different Stack Navigators to kind of create some sort of hierarchy between it. All right, so with these changes, with a little bit of tweaks here with React Navigation, what you get is that the average time between clicks actually goes down to 4.5 seconds. Not as exciting as we thought it was going to be, eh? So not really noticeable, but that's fine. We're going to go into our third experiment. Before that, I want to give a little bit of context again. Briefly talked about this, but I just want to formalize this concept of the Stack Navigator. So the way that a lot of navigation works on mobile phones is with stacks. You've got tab navigators and stack navigators. Tabs are the ones at the bottom. The stacks are, kind of think of them as stacks of paper. You can take different screens and just stack them on top of each other. Those pieces of paper are still going to be there, and they're still going to have all the information there. And you can remove one and see the one below it. So that's kind of how it works. And when in React Native or React Navigation, you push a screen onto the stack, the screens underneath are still there. They have all of the components still rendered. They're all mounted, so still in memory. And that's so that if the user wanted to go back on the stack, which you've got that back button in your sort of mobile app navigation, it's ready to take input from them, and they can do whatever they want back on the previous screen. So experiment number 3 was unmounting expensive elements after navigating away from a screen. This was our sort of last-ditch attempt. What we saw was we had a bunch of screens back-to-back that had lists that were computationally expensive, and we thought, well, these are the ones that are being re-rendered under the screen. Probably let's just unmount them and see if this works. So the way to do this, and I've got a very basic example here. How visible is that in the back? Decent? Okay, good. Glad. Okay, so very basic component. I've stripped out all of the side logic just to keep it as simple as possible. React Navigation has a use focus effect hook, which is really, really useful. And what we've done to kind of test this theory is we created a use state called focused, and based off of that, if the user navigates the screen and the screen becomes focused, we'll set that state to true. If it becomes unfocused, we'll set the state to false. Very, very basic. And we'd conditionally render our computationally expensive component based off of that. And this was the most MVP approach to it, just to see if this theory actually holds up. Just with that implementation, what you'll find is, well, it only keeps the visible list mounted, which is good. There's less stored in the RAM. The trade-off is that you've got that split second where the list is unmounted, poof, and then you navigate away to another screen. That is not pretty. And there's ways that you can fix it. It's not too complicated. You use the interaction manager and you delay the unmounting with that as possible. A little bit hacky as a general solution to like handle the logic of things getting mounted and unmounted in the background. You don't want to be going through your components one by one and trying to figure out which ones are computationally expensive, which ones are not, and then unmounting them. It's not a great solution, but it is something that will work if you're kind of in a bind. So let's look at that, and we'll go into a little bit more detail about why this is a hacky solution and what better alternatives there are to this. But the average time between screens, and can I get a drum roll? 1 second. Okay, we've confirmed things are rendering. They shouldn't be rendering. Let's dig a little bit deeper and see what's happening. So first realization was contexts are inefficient. So hidden somewhere in the React docs, we found that components calling use context will always re-render when any of the context values change. So even if you've got an object in your context that's being returned, that's got attributes that are being used, like a first name, the classic person example, a first name, the address, some other details, it's not going to only re-render the screens that are subscribing to first name when first name changes and address that address changes. It's just going to blanketly re-render everyone. So as we were going through each of those screens, you'd add a new screen to the stack, and those screens would be connected to a context that would be re-rendering every single screen under the hood on every single user input. So that was one of the hints that we had, was as you would go through more and more screens, it got ever so slightly slower and slower. So we were like, this is a bit weird. You can use memoization. You need to go through and optimize it yourself for each context. It's, again, you're having to make a lot of those decisions on when things render and when things don't render. A better solution is you want to use a dedicated state management library. And for these multi-page forms, they can really help. So if you use something like Jotai or XState, those are going to generally let you have things like selectors where they would only render the screen in the case where that specific data that you're interested in that screen changes. A good example here of where this like overall context causing an insane amount of re-renders happens is highlighted with this like wizard form hook. So previously, if you went back to the days of Redux form, things were bad in terms of re-renders, basically. So what you had, and this is from the Formic docs. So one of the questions that people would ask when Formic first came out was, why don't you just use Redux form? Is everyone familiar with Redux form? Okay, so for the ones waving their heads, it was a way to handle forms using Redux back when Redux was like the state management system. An interesting design choice because they stored the form data inside the global Redux state. And what that meant was that every single key press that you would do, it would send an action to your Redux state and process that. Multiply that by a massive like component tree or like a massive project, and you get a lot of re-renders there. So what the argument that Dan Abramov made was actually form states are inherently local, so you should be handling them inside a component. You shouldn't let context and overall state affect it. And then that was kind of the inspiration to build things that are more local based for forms. So that's where the wizard form pattern comes, which is keep all of your local state for the input fields that you've got and the form data that you've got very close to the screens, and then update the context or the global state after you've actually inputted the data. So yeah, that's kind of closely related to this. So lesson learned here, be very mindful of how you're designing these multi-page forms. They're very common in mobile apps. So you want to be very conscious about the choices that you're making. Use a state management library. There's a lot that are out there. Signals are coming to React, I learned today, which is exciting. Not officially, but there's, I think you can use Preact's version of it. So yeah, just use things that won't be insane in terms of re-renders. So I want to finish on tools and libraries on the horizon that can help with performance optimizations and measuring performance. Firstly, when we talked about context being inefficient, the creator of Jotai actually has another library called Use Context Selector. It's a slightly altered implementation of context. You would install it into your project, and instead of creating a context with the classic React context, you would create this specific context, and then you can define selectors as opposed to directly trying to access it with the use context hook. And so you would only get re-renders if that specific attribute that you're interested in changed. So if you're still wanting to use that context style API and you don't want to deviate too much from React context, maybe you already have a project that's heavily built using React context, this is something that you can probably plug in and play pretty easily. We talked about a few of those other state management libraries, Jotai, XState. You can look at that if you are obviously building a new app or you have the scope to change the state management patterns that you've defined already. Next up, React Freeze. This one was really interesting. So it's a library that's created to avoid unnecessary re-renders. So I think the folks at Software Mansion created this one. And basically what you do is parts of screens that are no longer visible to the user, they're replaced with a placeholder view that kind of replicates what that screen looked like. And then they're not unmounted, but they're kept as that unre-rendering and like not active screen. And then when you navigate back to the screen, it would be replaced back with what the components actually were. So this is another cool one. It's very similar to that concept of mounting and unmounting components, but with a slightly more well thought out solution, I guess. Lastly, this is a really cool tool that you can use with Flipper. So I think Alex Murrow was here last year. He was talking about measuring performance with FPS. So we had a very specific problem. We had a long loading time between screens, but more generally, you can measure FPS as a good indicator of if your app is responsive and if your app is quick. So you don't want things dropping below 60 FPS. So if you use Flipper, you can connect in this plugin and run through some of your flows of your app and see where your frame rate drops. And that's probably an indication that something needs to be optimized at that action or whatever you have. And lastly, this is fresh off the printing presses, but has anyone heard of Flashlight? I think it was somewhere on This Week on React. So again, Alex Murrow, he's from our team in France. The folks at BAM, they've been working on this for a little while now. They originally released it as an open source tool. It's already there as an open source tool, so you can use it. But it's quite cool because it's like Lighthouse, but for mobile apps. And the idea is that this isn't just a React Native thing, by the way. The idea is that you want to measure performance on Android. So every single output of whatever framework you have is going to be an APK. So use that APK, whether manually or as part of your CI. It'll run through a bunch of tests and measure the actual performance and give you a Lighthouse-like output of how your mobile app is performing. So it's a really cool project. Search it up. It's flashlight.dev, so the link is just down there. It's invite only for the cloud-hosted solution, but there's also the open source repo that you can plug into your own CIs and have it testing. This is really cool because it's, I think, one of the first times where you can really test performance in an end-to-end manner for mobile apps. So I think this is going to be groundbreaking in the next few months. I'm really excited to kind of integrate it into our everyday mobile development pipeline. Nice. Let's finish up with the main learnings. Have I been going really quickly? Cool. Okay. So 3 main learnings. Firstly, we did an awful job at defining a baseline phone. We were testing on medium to high scale phones. It really helps to define a low-end baseline phone. So a good example of this that our team in France uses is the Samsung J7. The way that they've actually chosen that phone is because it's one of the top-selling phones, if not the top-selling phone in France, which is where most of their app users are going to be. So it's good to take a little bit of time, analyze what phone might be a good baseline phone for you, and use that for performance testing, and make sure that you are consistently testing throughout this process. You don't want to be scrambling like we did at the very end, trying to get your app working on low-state phones. Consciously think about state management in your app. Contexts are bad, to keep it simple, or can be bad. There's a lot of tools that are out there. Learn the state of the art, see if you can use them, especially when it comes to these multi-page forms where a lot of screens are interacting with each other and it has some sort of sequential flow. And it really pays off to understand how React navigation works. So think about how you're architecting your navigators. Think about how you're structuring your navigators. Try not to keep them nested. Try to keep up to date with the docs, and it'll go a long way. Thank you very much for taking some time. Thank you all for listening. Please feel free to reach out to me on LinkedIn or Twitter. I love catching up with people over coffee and meals, so I'm always down to have a chat, whether it's virtual or in person.